Hello everyone. In this lecture, we will discuss the fabrication of BiCmos technology. So BiCmos technology is nothing but it is the integration of both bipolar technology as well as CMOS technology. So why it is necessary? In some cases, it is necessary to have the advantages of both technologies. That means in mixed signal processing, we require exclusively BiCmos technology devices. So BiCmos technology will have the advantages of bipolar such as high speed as well as low power consumption such as CMOS technology. So here we will discuss how to manufacture BiCmos inverter step by step process. The fabrication of BiCmos will start by selecting suitable p-type silicon substrate. So as we already know that first and foremost we require a substrate, so which is a pure form of substrate without any impurities. So we are going to take a good electrical conductivity substrate, that is nothing but p-type substrate, where we are going to add p-type impurities such as boron. So it will be converted into impurity p-type semiconductor. So now after that, the next step we are going to do is, so we are going to cover the whole substrate with oxide layer, so which is known as thermal oxidation. It will act like a insulating material for the another procedure steps. So next we are going to define active regions in order to fabricate bipolar device as well as CMOS technology devices such as NMOS and PMOS devices. So for that purpose we need to carry out the photolithography process. So where the wafer is coated with the light sensitive material known as photoresist. And after that we will carry out the masking procedure. So where entire photoresist is exposed to ultraviolet rays with the help of a mask. So here wherever we require openings, so that part is unexposed to the UV rays, and with the help of some chemicals such as trichloroethylene, we will remove unexposed photoresist, which is known as the masking procedure. And after that we are going to next we will carry out the burying of subcollector, so which will help in order to improve the electrical properties of a whole substrate. So here n-type impurities are introduced through the p-type substrate, so at the higher temperatures. So here this is known as buried subcollector layer. And after that the epitaxy layer, which consists of p-type material, is grown all over the surface. This will allow for better electrical conductivity. Later on the entire layer is covered with again oxide layer. So the steps are repeated once more. That means deposition of photoresistive material, and then the etching process, which is carried through the masking for the purpose of creating bipolar as well as CMOS devices. So next we will heat the substrate to the higher temperatures, and then n-type impurities are diffused to form N-wells. So inside the N-wells we are going to create one bipolar transistor and one p-type transistor, p-type CMOS transistor. Later on we require one more opening in order to form n-type device, that means n-type's mass transistor. So for that purpose the procedures are repeated once more. That means the oxide is deposited, and then photoresistive material is deposited, and then it is exposed to UV rays through the mask. So and the unwanted regions are stripped away. So and then we will create the openings in order to form CMOS device as well as bipolar device. And then we will form the gate terminals to the respective N-type transistor as well as P-type transistor with the help of a polysilicon. Next we will carry out the next procedure, which is nothing but the creation of bipolar transistor. So here first the substrate is heavily heated to the higher temperatures, and then N-type impurities are heavily doped in order to form the N-type emitter terminal of BJT. After that, since we require source and drain terminals of NMOS transistor also should be made of N-type impurities, so we will carry out this diffusion process to form source and drain terminals of NMOS transistor as well. And then we will form N-type collector. So inside the N-well, so where we have formed N-type emitter and as well as N-type collector, which is a part of bipolar transistor. So now we are going to fabricate P-type device inside the N-well, that means PMOS transistor. So here once more the substrate is heated to higher temperatures, and then P-type impurities are slowly introduced inside the N-well. So the terminals of a source and drain for PMOS transistors are created with the help of P-type impurities. So here we need to deposit one more terminal of BJT, that is nothing but P-type base. So here with the help of P-type impurities we are going to lay the P-type base terminal to the BJT. So here we have fabricated the complete bipolar transistor, so where emitter and collector are made up of using N-type impurities and base is made up of using P-type impurity. So since we have completed the overall deposition of diffusion, that means the formation of N device, the formation of P device and the formation of bipolar device. Now the next thing we are going to do is the metallization process. So for that purpose the aluminum is deposited all over the surface, and then it is covered with the thick oxide. Once more all the steps are repeated, that means deposition of photoresist and then exposure to UV rays and then etching away unwanted regions in order to create the patterns. So where we are going to take out the terminals outside. So that means contactors need to be formed. So here the formation of metal contacts along with the terminal contact cuts can be seen in this diagram. So overall device is packed inside a packaging and then it is sent for